It's going to mean an operation.
Hello, class. Oh, you got but one person in. Who is that? Mr. McDowell.
Yes, sir.
How you doing?
Oh, I'm all right.
How my project went?
Your first program was a fucking doozy, man.
We gonna go over it today though. But I
I think
want to.
I got it though, but
You
it took
got
me.
it?
Yeah, I'm fairly confident that I got it. It was working, and I think I
Okay.
did it. Yeah, so, but yeah, that took me quite a few hours to do, but I did get it.
Okay, all right, because they had a couple of emails. Mrs. Vesta, can you extend it? Mrs. Vesta, I'm confused. I don't know what. It's wow.
Yeah.
But what I'm gonna do? Some of them didn't understand the data file part. Reading from a data file. So I'm gonna
Yeah.
kind of go over that. Even though I had
That one I had to look that up, but once I did that part, the rest of it became easy because I was
okay,
like, you use the same method pretty much for everything else in the program, and I was like,
correct. That's right. Yeah, right. Because see, the data file portion came from I think chapter five of when you was in 193.
mm-hmm.
Yeah. So that's where that came from. Because
Oh,
most
I did forget that, but I just pulled up my old homework,
oh,
and then I
right.
was like, oh, that's it, that's how I do it, and I was like, perfect.
Right. But I'm glad you was able to think through it.
Oh
Some
yeah.
people just get frustrated, and just give up. Yeah.
Oh, I didn't say I didn't get frustrated.
Yeah, that's good though. That's all right. Yeah. Let a couple of more people log in, and then we'll try to get started. Because if I start and they don't catch the beginning, then there'll be something.
Right.
Yeah.
Little questions and yeah.
Right. 3 people. I'll tell you what I'm gonna do. Now let me ask you this: when you get the email for the Canvas Zoom session, does it send you like the phone number also to log in?
Let me see.
Because I might.
I haven't received it for today, but I'll look at an old one.
Okay, because what I might need to do is just send a
It
copy.
does send the
Oh, it
meeting
does.
ID.
Okay,
Yeah.
all right. Well, that's good. Yeah, so everybody should. I don't need to do it. So everybody should have that. Because that's what I'd be afraid of at times. Students away, from home, and they want to
hmm
use their phone.
Um, well, you have a Zoom tab that you I don't
Oh,
know.
in the King Canvas. Oh, okay.
Yeah, so I've always just clicked that, and I'm pretty sure
Okay.
you can do that through your phone too. So,
Okay. Yeah, because I've never done it through the phone. with Canvas, yeah. Give people a little while longer. We got 5. Anybody with questions? I'll start the lecture. Let other people log in. Anybody questions? Any questions? Hello? Williams, Jones, Russell. What's up, Miss Russell? How you doing?
I'm doing okay.
All right. Did my program?
I did. I wanted to talk to you about that later. I wasn't able to turn them in, and I know that it's closed now, and I wanted to see if there's any way I can get them to you.
Oh, that you could get them to me. I might extend the date though. You know, well, I probably will, because we're gonna go over it again today.
Okay.
Turn this off. Yeah. Because I do want you to do the programs. I'm not giving you assignments just to say, you know, don't do it or you won't be able to do it. You know, I'm giving them to you. You know, hopefully that you'll be able to catch on. So I still have about 5. So let's look at the notes. And we kind of started the notes, but I don't think we pretty much finished it. But we talked about arrays, all right? This would be your size declarator. And this has to be either a constant, you know, a literal, or either, you know, it can be the actual number. So, or it could be a variable. But it has to be constant, because once you declare the size of an array, you can't change the size, okay? This section here just gave you information as to when you're writing code and you allocating space for your arrays, you need to keep in mind how much space you actually being used or needed to be used. So right now, pretty much your programs can handle whatever you're going to be doing. But when you start working for a company or whatnot, it may be important as to how much memory space you use up to write code and whatnot. So that's why they're going to come to play. Like a float variable has like 4 bytes on average. So a float variable with an array of 100 would be 100 times 4, which would be 400 bytes needed. So stuff like that you would have to kind of know, especially if they gave you limitations on how much space you using. So, and this chart it give you that exact example. A char, 1 byte. If you got an array of 25 times 100, so that's 25 allocated space, byte space. Look at this last one, distance. Is float with 1,000 elements. So each element takes up 8 bytes. So that would be 8 times 1,000, which would be 8,000 bytes. So things like that, you know, you probably have to know when it's dealing with limited resources. But now we don't really deal with it right now because we don't really have to. This shows the like I say, a layout somewhat of an array. This is just a pictured version of it. You have like when we had days 6.
You're not sharing your screen.
Oh, I'm not. Oh, excuse me. I'm sorry about that. Let's see. Okay, we go. All right, here we go. There we go. Let me minimize this. All right, so now we have this layout here. This is just a pictured image of what your array could be. So your array is laid out into consecutive byte spaces, all right? But what happens is if we using the example where we had, hours 6, but hours is a what? Short. So what that means is you got 2 bytes for the first value to be stored in 2 bytes for the next one, 2 bytes for the next, 2 bytes for the next, 2 bytes for the next, 2 bytes for the next. So that's 2 times 6, because 0 to 5 is 6. So that's 12 bytes starting here and ending. You know, this would be the end of it. All right. So what this says is each array position is represented by a subscript. All right. And the subscript starts always at 0. We count starting at 1, but the computer starts its count at 0. So you have, this would be what it was, hour sub 0. Whatever the value is, that hour sub 0 is equal to that. Hour sub 1, hour sub 2, hour sub 3, hour sub 4, hour sub 5. Okay, so that would be the way you would reference the values at those locations. So this page gives you or depicts basically what a program statement would do. Hours sub 0. All right, that's how you would read this. Hours sub 0, and it's assigning what? The value 20 to hours sub 0. So this is the hours array. The sub 0 position is the first position, and it's storing 20 into that location. All right. Look at this. Hours sub 3, all right, is equal to 30. So it's assigning the value 30 to hours sub 3. All right. And we look here, it would store 30 at that location. So that's how you can put data in your array by specifically using those constant values to put it in there. But most times when we're dealing with arrays, we manipulate them using loops, all right? So, but we'll get to that. If you look at this program, this is pretty much the long way or the inefficient way of writing code dealing with arrays, okay? And I'll show you later on the way it would be done. But anyway, if you look at this, you have what? Cn, you have an array specified to be, you got your 6, which is your constant value. Then you got hours sub 6, int hours sub num employees, which is equal to 6, and it's constant. Then, so this array has 6 elements, but then you say enter the number, enter the hours worked by, and then 6 employees. So now you got Cn hours sub 0, Cn hours sub 1, Cn hours sub 2, Cn hours sub 3, on and on and on. So that allows you to input the values. All right, and notice there's only one statement that says input 6 employees. Then here's where you would output it. Cout hour sub 0, space hour sub 0, 1, space hour sub 2, space hour sub 3. Now, so you say, well, why would you say that that's inefficient? That's because if I said, now I wanted you to input 1,000 values, all right? I wanted to make your the array size of 1,000. How long would you think it would take you to write this code? You understand what I'm saying? Or you copy and paste, then trying to count, making sure you got all your number elements is in sequential order. You didn't skip a number, all these things. So those things will come into play, all right? But look, if you would just do an array, start your what? Excuse me, not array. If you do a for loop and start your for loop at 0 and end your for loop at the size of your array, which is your size declarator, and then what? Continuously prompt the user to input a value, then no matter what size the array is, what? All you're doing is inputting the value, inputting the value, inputting the value. You're not trying to keep count of how many times your loop incremented. It's being done through what? The for loop, okay? So that's why many times we use a for loop, because it's more efficient to manipulate our arrays. So if we go through this example here, this example sets our array size or our constant value of array size to 5. Then we say int numbers array size. So when you see a variable name in the square brackets, or the data type variable name in the square brackets, that it signifies that numbers is an array. Whatever in the bracket is the size of the array. All right. So if you look at this for loop, it says for int count equal to 0, count less than array size, which is what? 5. So you're going to start at 0 and end at 4, because when you get to 5, it kicks out. Okay? You got to remember that. 5 will not be a process, okay? Because 5 is not less than 5, 5 is equal to 5. So each time it goes through this loop, and notice it don't have the curly braces at the beginning or the end. By default, a for loop will only, if it doesn't have curly braces after it, like the open and close after it, it will perform the next statement that many times, all right, by default. You're saying that I only have just that one line to perform in this for loop. I'm going to perform it so many times and then continue. But I normally say, put your curly braces, because whenever you have to modify your program, you can do it much more easily, you know, knowing that, hey, this is my body for my for loop, so I can add my values in there and not have to worry about, oh, I forgot my curly braces. Now my logic is all thrown off. Okay? Now, this is the program, the same program as this. So if you notice, this got CN 6 times, C out 6 times, all right? And then you have to put the subscript in each one of these hours or whatever. But if we look at this program is doing the exact same thing. Enter the number of hours worked by employee, and it says, and then this is going to output count plus 1. The first time through, count is 0. So 0 plus 1 is 1. Now, you got to understand what's happening here. It's not adding 1 to count. Well, right. It's not adding 1 to count. It's saying take whatever count is, add 1 and give me and display that value. But count is not being changed at this point. You're not assigning anything to count. Now, if you would have said count is equal to count plus 1, then you would be changing the value of count. But at this right here, all you're doing is saying display whatever count is. If count is 25, you know, output 25 plus 4. All right, you didn't change 25, you just added to it and then gave the result. So that's what this says. So each time through, you're gonna output hours worked for employee number 1, employee number 2, employee number 3. But here is where you see in your values. CN hours sub 0, go back through sub 1, through sub 2, go through sub 3, sub 4, sub 5, and then it kicks out. So you don't have to be writing that C out statement 6 times, 5 times, 6 times. So now, once the data is in an array, and this is something that you need to understand. Once data is stored into an array, it's held there. Just like you store data into a variable, like if I say int x equal 5, the value of x stays there until my program ends or until I overwrite x. If I store values into an array, that the value stays into the array until I either overwrite them or either, you know, exit the program. All right. So I can store data into an array, use that array, those values in the array, manipulate it to get values, use it again for x equals 0 to 5 or 6, 0 to 6 or less than 6, do whatever. Use it again, do whatever. So as many times as I need to use my array, I can use it, you know, as long as I don't wipe it out or store 0 or no, put blanks in them, you know. So now, so this is telling us about that that subscript here, count minus 1. What they did was they started their loop count at 1. Okay, over here, right? What we started, I'll put it like this. What they started their loop count at. Let's see. I don't want to go that much. All right, I'll just leave it. They started for count equals 0, count less than num employees, count plus what? 1, count plus plus. But look, for count equal 1, count less than or equal to num employees, count plus plus. This loop performs from 0 to less than 6. This loop performs from 1 to 6, less than or equal to 6. So each one performs 6 times, but if you look within the loop, now when I do a CN, I can't CN count, all right? Because what? I'm starting at 1. So my first value in my array position is always 0. So I have to say count minus 1, and I'll say, which is 0, so it's gonna CN hours sub 0. Just programming style. That's all it is programming style. But as long as you understand, you know that you start inputting data into that first array position and then increment after that. Because the next time through, it's gonna say end of the hours, for employee 2, but then it's gonna say CN hours count 1, not 1, 2 minus 1, and 2 minus 1 is 1. So it put information in the first hours of 1, sub 0. Now it's putting in information in hours of 1, and on and on and on. All right. So that's all this part is kind of showing you. All right. Now, anytime you declare an array of integer, of a numeric array, whether it's int or double, you cannot just say cout and then the array name. Cannot do it. You cannot do it. All right. You cannot do it because the array has to print out each individual element. All right. You have to reference each individual element of the array to output it. All right. So you cannot do that. Dealing with char is a little different, but with integer data, this is how it works. All right. Now, these were the 2 assignments. You could, let's shift it up. You could still do them for practice. Okay. What these assignments does is the first one allows you to type in a program that is running or that is correct. Also have a data file, 20, 12, 4, 3, 30, 30, and 15, and a read from that data file, as long as you give it the right name, and print out the data. But I'll show you that in a little while. We'll go over that, and then this one writes to an output file, all right? Because that's what this class is going to be dealing with, and that should become second nature to you for this class, reading data from a file. Because I'd say 95%, 99% of your program going to be reading from a data file. 99%, or all of your, not 99% of your program is going to be using a function or get using the input, process, and output function. All of your programs, or most of all of your programs. All right, but that's just some assignments that you can do. That's just I got all the way out. All right, you can do those. Now, no bounds checking in C++. What that means is in C++, when you start dealing with arrays, all right, your array position, a subscript, you might input a subscript or reference a subscripted position that's not a part of the array. So look at this example. They just showing you a array called values. Now, the array called values has allocated 3 positions, sub 0, sub 1, sub 2. But they just showing you what could happen. What could happen is you could try to reference sub 3 and actually store data in that position, which you might be destroying some data in your program. Because what? Depending on the data type of this value, if it's int, if it's short, it's 2 bytes. If it's int, it's 4 bytes. So what happens is, if you store data here, but you had something that went from here to here, and it was 16 bytes, you just took away some of the bytes that and changed them, and now whatever in these fields is referenced in a different way. All right. And so when you try to access a variable that's supposed to be using these spaces, it can cause issues. All right. So even out of bounds checking, you may be thinking you're writing to your array, but your array only goes up to the sub 2 array position. All right. So when you start manipulating, when you start saying, okay, I want to capture this, you might get an error saying, oh no, you're out of the boundary. All right. But going in, sometimes it does not check the boundary, but it can cause your computer, and as they say in here, sometimes to crash, because the data that it try to pull maybe for another variable value that you don't overwritten, it done damaged it. It could have been text data. It could have been Boolean data or whatever, and you done just overwritten it with some integer data or whatnot. So you done caused the program to have data in there that erased some stuff out of it. All right, so you gotta watch that when you're dealing with the sizes of your arrays, not to go out of the boundary, because it won't check it for you. All right. Now, off by 1, like we said, in computer science, you start programming starts at 0. Okay, always it starts at 0. So what happens is, if I have const int size equal 100, then int number size. So there is 100 elements of number. Okay, don't get that confused. But this loop here goes from 1 to 100, which would be wrong, because the computer starts at what? 0. All right, so you got to make sure you start at 0, you're going to be off by 1. Okay, and that's what they're talking about, that off by 1. Rather than storing the values in numbers sub 0 and continuing, you're storing values in numbers of 1, 2, 3, 4, on and on and on. And so if somebody who programs, or either the data file that you're creating, and you're writing it to you're writing that array, then somebody writing that array out, they're going to be writing out either a blank array value, and then the rest of the data, which could be a problem. All right. And then you're going to miss the last one. All right. So initializing, your program told you to initialize what? The names, right? Now, this is not initializing character data, but if we look here, this is why we initialize character data. But now, I mean, not character, but we're dealing with string. So normally what we would do string, and then name, and then a number. But then when we do that, I'll have to show you, because char data deals with what? Single characters. So, and we'll talk about that. But a string data, you're dealing with a string of characters. So it's almost like a 2-dimensional array. So let me give you an example of that right quick. All right, let's open up something. I'll open up homework. So the program instruction said to initialize an integer array. I mean a string array. So what? if I'm going to use strings in my program, I have to what? Load the string library, right? I can say. Now then I can say, okay, string name. Now, just doing string name, that's just what? A single character, a single variable, right? That can hold what? A single value. What I can put in name? One series of characters. Could be my name, could be the school name, could be a book, could be whatever, right? But when I do this, I'll make it 4, if I could tell you. When I do this, all of a sudden now I'm saying I'm gonna have 4 different strings, all right? That means I can have 4 different names, 4 different titles, 4 different schools. You understand what I'm saying? Because now I have 4 series of characters, right? Because string name by itself is just one series of characters. When I make it an array, I have 4 series of characters. Now, if I wanted to initialize that name array, which means I want to give it values and say I was giving some names, I could say, okay, I could do this, put double quote, because it's what? A string, comma, and then I have to give, well, I don't have to, but if I want to fill up my array, I'm going to give 4, all right? All right, another one, I'll tell you. All right, and another one last one, what? All right, I gotta put them in what? Double quote. Now, so these are the names. My array, I need to close it with the curly braces. So now my array has been initialized, right? A name has been initialized to Kevin, Brad, Thomas, and Otis. So those are the 4 values. Now you say, well, Mr. Lester, how you know that? Well, if I do this, for int, let's say x equals 0, x, I can type, x less than 4, x plus plus. All right, now I could just put the C out without the curly braces, but I just like to have them C out. And what I'll do is I'll say, I'll just put space in front. I was doing it right. Name sub what? Sub x. X is 0, x is 1, x is 2, x is 3, kick out. All right? Now, so I'll say, okay, let me check to see if my names have been initialized properly. All right? So now I run the program. Taking a while. There you go. All right, so you see, my output became Kevin, Brad, Thomas, and Otis. So I do see that what? My initialization for name does work. All right. So all I did was just put a little check to see if everything was okay. And then I could comment this out or take it out. All right. Now, and I'm kind of getting into your program. So your program talked about reading in data for each individual name or person, all right? Your program, you had 15 names, right? And each name had 5 scores. So in this program, we'll have 4 names, and then I could say each person have 3 scores, all right? So that would be what size, and then I want to put my data in, I want to input the data in a two-dimensional array, because I don't want to keep creating 4 different arrays for every student. So let's go back to the code right quick, and not here. To the code right quick, And so we know how to declare, well, this is initializing. I did and the months 12, okay, constant. Then days, months. So days is 12. So you got the days for first month, which is sub 0, sub 1, sub 2, sub 3, sub 4, sub 5, sub 6, sub 7, sub 8, sub 9, sub 10, and sub 11. So 0 to 11 is 12. And basically this is storing the largest day of the days in the months for each month. So that's all this array is doing. And it's just showing how you can split it up by comma and then starting on a new line, but you still have to end it with the curly brace semicolon, all right? Partially initialize an array. You do not have to initialize the entire array. You could set an array to be 1,000 and only use 10, but now you're just wasting 980 or 90 memory locations, all right? But you don't have to use up all of the array. You know, you don't have to initialize, but you have to consecutively initialize your array positions. What that means, if I took this 2 out of this and just tried to initialize this array, I would get an error. I would have to wherever I stop giving values, that's it. I can't beyond that, I can't initialize anything else. So I can't leave it blank. I can make it 0, but I can't just say take this 2 out of here and put 1 comma space comma 4 comma 8. I'm gonna get an error. Okay, I will get an error. All right. So and if I give you an example with this one, even though it's like this, I should get an error. All right, because I cannot skip one. See, I skipped one. You cannot skip. You know, you have to consecutively. Oh, this is the old one. I just told it to run the old one. So that's why I did that. So you cannot skip. Oh, I don't want to undo. There we go. All right. So now, back here. So we can partially initialize it. Now, implicit array sizing. What does that mean? That means if I have a list of numbers that I know I'm going to be using, rather than me, or either a string or characters or whatever, rather than me trying to count the number of elements I have and then put the number here, I could just put in all my values and leave my size declarator blank as long as I'm initializing it. I don't have to put in a size here. And whatever values I have in my list, a compiler will count those elements and make your array that size, you know, automatically. All right, so it would automatically give you the size of the array. Now, you're talking about char data, all right? Notice this, char name 7. How long is Warren? Warren is how many characters? Huh, class? Warren is how many characters?
6 characters.
6 characters. But what we gave the size of name?
A null terminator.
We had to do it. We had to add. We have to account for a null terminator. See here, name is 7. If I just said name is 6, it won't give me an error. But when I try to output it, it will not know when to stop outputting until it finds a null terminator somewhere in the memory that where it's printed from. All right. So that's why when you declare a name, in a char variable, you add 1 for the null terminator. All right. You always add that 1. And now look, you can declare name with all of these at once. All right, or look down here. You could initialize, or you can initialize name with what? Individuals, because char what? Single character, comma, 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 this is 2 characters. No, it's no, it's a escape sequence, and all escape sequences represent 1 character. So this is 1 character. So that's the \0, which is the null terminator, right? \n is an escape sequence. It's the what? New line, right? Remember? So that's how you would have, if I told you to declare a char array of so many and individually initialize each element, then this is how you would do it, which I won't ask you to do it. But I'm saying that's so you have it in your mind. All right. So it's telling us the same thing. I could do this. Now a computer will automatically say what? 1, 2, 3, 4, 5, and add the 1. The computer will always automatically do that. Make it 6. But when you individually give the sizes with each one individually with the single quotes, then you have to add the null terminator. But in this one, the computer automatically adds it and then add the size. Here, it will count up until the last one because you're individual. And so if you leave this off, then when you try to print it, it's gonna mess up. Your program will mess up. All right. So processing array content. Now you got to understand with plus and minus. Right here, I'm doing a plus on score. Well, let's do this. Int scores sub 5, and we putting these values in here. Then we got plus score sub 2. Score sub 2 is equal to what? 0, 1, 2, 9. So it's on an increment 9 by 1. You understand what I'm saying? So,
yes, sir.
All right. So this one, score sub 4 plus. It increments after it leaves that line, increments score sub 4, which is 11, by 1. After it leaves that line, not on that line. Now, but what happens with this? You got to understand. Now, we know that this will decrement because it's outside. So whatever amount of count is, it's going to find the element and subtract 1. But look right here. Count minus is what? It's going to take 1 from count, all right? Go to that particular subscript and then give you the amount. You understand what I'm saying? So you got to be careful as to where. And let's go back up here where we have score sub 4 plus. If I did a score sub and then 4 with the plus inside the curly braces, the square brackets, it would try to do score sub 5, which would be an error. You understand? Because I'm incrementing 4 to 5 and then score sub 5 to try to find that value. If the plus was inside here. All right. So you got to kind of watch and understand when you're writing code. Those little things can cause major headaches. All right. So here we have the little program. This one dealing with show point. All right, everything. All right, and dealing with gross pay. But now watch what happens. It has an array called hours. All right. Well, let's see. Yeah, array called hours. I thought it had something else. No, just hours. So what? Yeah, it should have another array. I see hours. I see pay rate. All right. Oh no. Okay. Yeah. So pay rate. So yeah, you're getting the gross pay. So what happens is, in this program, you're going to input all the hours for the employees from 0 to less than 5. And then what happens is, you do a C in here. You input the pay. Then you're going to say, you're going to see out the first person when I went up here. You're going to do right here. Double the gross pay is equal to hours of index time pay rate. So apparently, you inputted a pay rate. You inputted a pay rate, and then you fell into this loop, and for every employee, apparently they're gonna have the same pay rate, and you're gonna calculate a gross pay for those 5 different employees. All right, so that's what this program does. Calculate the pay rate for 5 employees, not the pay rate, but the gross pay given one particular pay rate. Because once you put the pay rate in, then it goes in and calculate the gross pay for each student, each employee, based on the what hours that were entered at this point. Okay, but they're all getting the same rate. Now, so if we can reference values of a subscript, an array position, we can compare them. All right. So look at this. If cost sub 20 less than cost sub 0, it's not talking about the array position. It's talking about the value at that array position. So what happens is, let's look at, let's see where we got an array at. Here, let's look at this. So if I ask if num sub 0 greater than num sub 2, that would be true or false. Num sub 0 greater than num sub 2. Anybody? Or numbers? Number sub 0 is greater than number sub 2. True or false? Anybody? Hello? All right, that will be false because num sub 0 is equal to 1. Num sub 2 is equal to 4. 1 is not greater than 4. All right, so you're referencing that the value at that position, okay? You're referencing the value at that position. All right, so where was I? Right here. So that's all it's telling you, all right? You cannot, all this saying is I cannot make one array equal to another array. I have to copy each individual element from one array into another. What this saying is I have an array called old values, and then an array of the same size and the same data type called new values. I cannot say new values is equal to old values. Cannot do it. What I would have to do is, based on the size of the array, go from 0 to the size and say the new value sub count is equal to old value sub count. So sub 0, then it goes back through sub 1, goes back through sub 2, goes back through sub 3, and until you get to the end, and it'll kick out. All right, but it'll take each individual value and store it into the new array. And you're doing that one at a time, all right? Printing the content of array, we saw that where you could just say cout, and you have to use the subscripted value, okay? You have to do cout and the subscripted value. But there's one exception. Remember I told you, with char data, there's one exception to the rule when it comes to char arrays. I can do this. Char name is equal to root. It's gonna what? Take all of this and add a what? Null terminator and make this size what? 5. And then when I do cout name, it's gonna cout RUTH, null terminator, and I'm finished. So it will know to print from the beginning to end when you're dealing with the char data, all right? Now, this is just a program. Let's get to two-dimensional arrays, because that's what your program dealing with, all right? Two-dimensional arrays, parallel, let's see, comparing array. Now, class, this is what you're gonna be using in your program also. Passing arrays by arguments. If you notice in here, you have a function, well, you have the main function. And then you have a function here called, that's defined down here called show value. We have the prototype up here. Now, in this prototype, it says I'm passing an int value. What are we passing is the individual value of the array. We're not passing the entire array here. So notice, it says show value, and then it say number sub X. So whatever, index. So sub index, sub 0, sub whatever. So number sub 0 would be 5. The first time through is passing 5 to num, and it's going to print out num, and on and on and on. That's passing the array value as an argument. If you want to pass the entire array, which is what I want you to do in your programs, here is how you would do it. Void, here's show values, but then what? Int, and then the square bracket says that I'm passing an int, but it's of an array. All right? And then I'm gonna pass the int, and normally that int is the size declarator that you're passing. All right? So this is the actual array, and this normally is the size declarator. So look here. Same exact program, but this time we just passed the entire array, did what we had to do here, and then we finished our program. But look, show values, we got our prototype, show values, numbers, okay? So numbers is what? The actual array. So we passing, and really what we passing is the address of the array, but we passing numbers. Then we passing array size, and array size would be what? The size of the array, which was what? 8, all right? So now we passing the array, which is numbers, and we passing the number in the size, which is 8. Now, in this for loop, for index equals 0, index less than size, which is 8, then it says see out nums, because see, nums is the array that we pass it to. We pass numbers to num. We pass array size to size. So int numbers, nums. So here we got int index equals 0, index less than size, index plus plus, see out nums sub index. So now we in the function, and we got our array that was passed, and now we processing our data. We outputting it, okay? Now let's write that code so you can see it. Looking at it on there and say, okay, well, Mr. Sylvester, I see, but I don't know. So let's do this. Well, I'll just leave that there. That don't matter. If I do something like this, int, I'll say num, and I'll say I don't put anything, but let me do a size. Const int nm equal 4. So I'll make my size 4. All right. Then I'll say curly bracket 20. If I could change 40, 60, 80. All right. So now I have that information in there. So now what I want to do my prototype, I'll do void process num. Now, I want to pass the array. So what my array type is, it's int. So I'll pass an int, but what? Let me go back. It's an int, and it's a what? An array. Then I want to pass my size declarator, because I always want to keep that, and it is what? 4. So, but the data type is int. All right. So that's my prototype. So in here, I declared my array. I have my size declarator. So now I want to call my function proc num, but then I want to pass num, and I want to pass nm. Okay. So I'm passing those two values. All right. Then now I need to define my function. In defining my function here, I'll say void, because I use void at the top, proc num, and then what? Now I need to tell it or introduce my values that I'm passing. The first one, num, is an array. So what the data type? Int. Well, it's an array. I'll call it numbers, and then I'll put this saying that it's an array. And then I'm passing a int value. Num is an int value, so I'll say int, and I could just call it CNT, whatever I want to call it. That's what is going to be used in this area. So now I could write a for loop. I could do a for int x equals 0, x less than CNT, right? X plus plus. Now you say, well, why less than CNT? CNT was NM was passed in the CNT. NM is the size declarator, which is 4. All right. So this is gonna go from this should be equal. Go from 0 to less than 4. And then what I want to do, because of that, I want to do a cout. And I'll say it would be what? What's the array here? Numbers, right? Sub, what's the subscript that's incrementing? X. X is incrementing. All right. So now, and this is the call function. So when I run this, I've just created, oh no, something wrong. Let's say, no. Let's see how I did. Oh, NL. All right, so now we got it. So let's debug it. And we should get 20, whatever. Oh, something ain't resolved. Something's not resolved. What's not resolved? Okay, this are int numbers, okay. That's, okay, now array. That's an int. That's an array. Oh, no, I didn't spell this right, class. All right, so now I could run it. Debug it. Look, 20, 40, 60, and 80. So what? Rather than me printing it in the main, I pass my entire array to proc numbers, and then I printed the data. So in your programs, you pass an entire array of student names, and then you process it. Now, so let's get to the meat of your assignment, okay? Let's see where we at. All right. Two-dimensional arrays. Here we go. Two-dimensional arrays, you can read through this, but two-dimensional arrays deals with rows and columns, all right? What happens is your data, your values inside of the arrays are referenced by a row number followed by a column number, okay? So this position here, well, first of all, let's look at this. We have a two-dimensional array of what size? 3 by 4. You say, well, Mr. why he says 3 by 4? Because I have 3 rows, 0, 1, 2, which is 1, 2, 3, and 4 columns, which is 0, 1, 2, 3. In actuality, is 1, 2, 3, 4. So I have a 3 by 4 two-dimensional array. So how is data referenced? How is it inputted? That's the same question. What happens is the first element is, in this one, scores is the array name. Scores sub 0, because it's on the 0 row, 0 sub 0, 0 row, 0 column. If I step over, it's still row 0, column 1. Step over, still row 0, column 2. Still step over, it's row 0, column 3. When we get to the next line, it's what? Row 1, column 0, row 1, column 1, row 2, row 1, column 2, and row 1, column 3. And it continues that way on and on. And if your array size was larger, you just have more columns or either more rows. Now, so let's create a data file. Some students like, Mr. Besser, what? I don't understand what it is I need to do, how, whatever. So say we have 4 students, okay? We say that each student have 3 test scores, all right? So now, in thinking on that, what will be the size of our array? We're gonna do a two-dimensional array. 4 students, 3 test scores. What's gonna be the size of our array?
15 and 5 for your two-dimensional.
No, not the assignment. This one.
Oh,
We're gonna take this one. We got 4 students with 3 test scores.
so 4 and 3.
Right, it's a 4 by 3. So the one that we just did in the notes was 3 by 4. This one gonna be a 4 by 3. Now, you say, okay, well, Mr. Investor, how would I create my data file? Okay, what you simply do is, first of all, we need to know what type data we need to put in it, right?
Yes, sir.
I told you that all your scores should be of what? Integer data type. So we're gonna right-click on source. We're gonna go to add. We're gonna go to new item. And now you'll click on utility, all right? And then you'll click on text file. And then you could give your data file a name. And I'll just call it data, or score data. I'll just say score data, underscore data, .dat. I'll just say score data.dat. And click add. Now it's gonna create me a blank file. Now we said our dimension is 4 by 3. So for each student, I need to put in 3 test scores. How many rows I have? 4. So this the first row. I'll put in 100, 100, 100, 100. I said 3. All right. Then the next one, I'll put in 100, 90, 100. Oh, no, 100. Then I'll put in 80, 78, 90. All right. So now what? This is a what? 1, 2, 3, 4 by what? 1, 2, 3. Everybody see that? You might say, well, Mr. Sylvester, the numbers are not aligned evenly. Does not matter. As long as each number has a what? A space in between. So you say what? Number, number, space, number, space, number. That's 3. 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 Now, looking at this data, you say, okay, well, what does this mean? What does this mean? Let's look at it. For the first one, this person has a 100, 100, 100. Let's look at this. So which student in here made all 100s? We got Kevin, Brad, Thomas, and Others. Which student got all 100s?
Kevin.
Kevin. Because what? The first record is Kevin. If I would have told you to input the name too, then you would have had Kevin, space, and then whoever, Brad, space, Thomas, space, and then Others, space. So then you would have saw Kevin and his scores, Brad, his scores, Thomas, his scores, Others, his scores. So you understand what I'm saying? But I told you to initialize what? The names, right? So the first name, second name, third name, fourth name. All right? Okay. So your program should be something like this, but you're going to have what? Five numbers going across, or scores going across on 15 rows going down. Now, so let's close this. Well, let's see what, I know the name. So in order for me to use a data file, what's my header file I need to use? F-stream. Right. So I need to use F-stream. So I have F-stream, and in order for me to know what type data or what data file I'm using, IF or what? OF. IF is for what?
Inserting.
Right. Well, for input file. OF for what?
Output.
Output file. Right. And we're gonna go over flags where you don't have to use that, and you'll be able to change it to whatever you want. All right. But IF stream. And like I say, it can be done whatever in data. Now, so I have IF stream in data. So then we can do what? No, I have to do it. I can do it in here or either do it where I'm reading it. So now, let's say I'll take this out. I'll take this out. All right. So now, why number? Oh, I know why. All right. So we take this out. Oh, I took the wrong thing out. Yeah, I know I took that out. That was right. Then I need to do int num. All right. And num is
a 4, 3, 4 by.
Yeah, but num, yeah. nm. nm, and then this would be the 3. Let's see. What I'm gonna do, I'm gonna make it where I can understand. I'll say row. Okay. All right. So nm, well, row. All right. So that's gonna give us our two-dimensional a specification for our row and our column. So now what happens is now up here, I cannot just pass what? In like this. I have to do what? Specify and give the column. All right. Or not. Now, if that's the case, then I need to move this up. Okay. Because what happens is now I'm declaring my array, and the array, not the array, but the size I'm using inside it, it doesn't know. But I could have put 4, but I want to use the variable. All right, because these are constant. That'll be throughout the program. They won't change. All right. So now here we have this. All right, and this would be what? Row. Okay. All right. So now, so we have this. Now in this part of the program, now we need to read in our data. To read in your data, you need a two-dimensional, you need a nested loop, all right? So now here, first of all, we want to pass, not seeing, this we'll call it row again. And like I said, I'm just using the same here, and this would be num, because the column is the second part. Normally, by default, they'll send the second part. All right, that's that. Okay. Now, okay, so for x equals 0, x less than what? How many times I want to read, how many rows I want to read? Because row would be the outside. Well, this would be, I just told you the answer. So this would be what? Row. All right. So I'm reading 4 times, right? All of the rows, all right? But then in here, I'm going to have something like for int y equals 0, y less than the columns y plus plus. So now what's happening? And I'm going to show you. Let me put my curly braces. All right. So now what's happening? When we go here, when row is 0, all right, we fall into that loop, correct? When row is 0, we fall into that loop. Then column gonna be 0. Then column gonna be 0. Column gonna be 1. Column gonna be 2. Kick out. We go back. Row becomes what? 1. When column is 0, column is 1. Column is 2. Kick out of that loop. Get back to the outer loop. Row is 2. Column is 0. Column is 1. Column is 2. Kick out that loop. Row is 3. Column is 0, column is 1, column is 2, and we kick out the inner loop, kick out the outer loop, and we finish. We finish reading in the data. So let's look at it, all right? So if we look at that, we want to do what? Data in, if I did I write data in? Oh, did I call it in data or data in? Oh, I didn't even give it the
in data.
Right, but I didn't give it the
you didn't open it, or
right? That's what I'm saying. Right. Let's see if I can do it here. Data. What I call it though? Data.
In data.
Yeah, man. All right.
It's early in the morning.
Yeah. Indata.open. And then we had what?
Score underscore data.
Yeah, it's up at the top. Yeah, score underscore data dot dat. All right. So
I did want to say for my homework, I didn't pass a constant variable. It didn't say I had to, so all I did was just pass an actual number inside.
right, like inside here.
Yeah.
Right. But try, like I say, when you write your code, try to do the variables, and especially if you know they won't change. Because if I were to tell you, say, okay, Mr. McDowell, you've done the program. Modify the program to read in 100 elements. I mean, an 8 by 8. You understand? Now you got to go and figure. Well, okay, I got to go change this one. So it might take you longer because you may miss some, and it tells you, oh, this needs to be changed. And sometimes you can't just do a search and replace because you may be using that number somewhere else in another number too. But if you use column and say, well, oh, my column changed, go over here in my constant, change my column, change my row, and now you don't have to change anything else in your program.
Right.
Because it's all done based on the size of your row and columns that you set it. Even the size of what? That array right here. Yeah. Automatically set. So that's the reason we say do it for efficiency purposes. All right.
Okay. So now I'll get into the habit.
Right. So now so this is our array here. So what happens here is now we want to do and I think we call it Indata, right? Indata, and then we want to do what? Numbers, and then what? Sub what? Now let me see if y'all understand what I'm doing. Huh?
You would put row in the first element and columns in the second element.
Huh? I would put what?
You would put rows in the first element of numbers, and then you would put columns in the second element. And
what row equal to here?
Oh crap! You would put X and Y. I wasn't paying attention. I did mine where my row was
increment. Yeah. Right. So, but you see what I'm saying? And then different people think different, right?
Yeah. Because instead of X and Y, I did row and column.
Right.
And my for loops.
Right. And see, when you have nested loops, remember when in 193, like I said, when you fall into this, X is 0, right?
Yes, sir.
Then you fall into this loop, Y is 0. So X gonna stay 0 and Y gonna go from 0 to what? 2, right? So you're gonna have 0 sub 1, 0 sub 0, 0 sub 1, 0 sub 2. Kick out, X becomes 1. Then you're going to go in here. Y, it's going to be 1 sub 0, 1 sub 1, 1 sub 2. Kick out, X becomes 2. Then Y start at 0, 2 sub 0, 2 sub 1, 2 sub 2. Kick out, X becomes 3. That's a home phone. Then you're going to have Y sub, we're going to have X sub 3, Y sub 0, X sub 3, X sub 3, Y sub 0, X sub 3, Y sub 1. X sub 3, Y sub 2, and kick out in your finish. All right? So, let's say, for just for the sake of it, we want to print out, we want to see if our data is actually read in right. So what you do in order to print it out, I have to do a nested loop to do that too. So what I'm going to do, I'm going to copy this information. I'm going to do this just say for to save time, for that from going to 0, that going to from 0 to 4, 0 to 3, and then right here, rather than say this, I'm gonna say what? See out, right? Right. And then I might want to put a new line. Not a new line, blank spaces between the numbers so that you can see them. All right. Now, but looking at this. Each time I get to a new row, I want to do what? I might want to do what? See out a new line. You understand? So you understand? So you got to know where your level stop. So I'll do a new line. So let's run this, all right? And this is not actually your program. See what I'm saying? So what? Now I can compare this with what? Go back to here. So I can compare this with this. Let's see. 100, 100, 100, 100, 90, 100, 80, 78, 90, 99, 95, 92. So I know my data was what? Ready correctly, and I'm referencing it correctly. You understand what I'm saying? So if you take your program step by step by step, it'll help you from making all these big errors because you're really making changes to something and you got errors somewhere else that's causing it. All right. So now,
how important is it to close a data file?
It's right now it's not really important, but when you start dealing with multi-user systems and like say I'm dependent on a file that you have open to run my process, it becomes very important.
Right.
Right, become very, very important. But this is more or less standalone in a sense. You know, I created a file. I'm using this computer. I use the file. I get out when my program finished. Nobody else is asking for it or wanting to make changes to my file. Right. So it's not that important here, but it is important. You know, it is important. And don't just take it as well. We never did. No, it is. And a lot of times I might not do it in the program, but it is important. Now I'm gonna show you something. If I wanted to calculate the average, so what I'll do, I'll create me an average function, right? I'll do something like this, int average, and it's what? An array. And this would be, if I'm doing the rows, it would be for a row, right? And now I've just created a function, not a function, an array for average. So now this ran in the data. So let's create a function to process the data, all right, or to calculate. All right, and what we want to pass, we want to still pass num, our num array, and we want to pass row. All right, everybody got that? Well, then also we want to pass what? Average. Correct? Because we need to calculate the average and store the average into the array, into the average array. But look, I'm getting an error. Well, I'm getting an error on calc because I didn't do my what? My prototype. So void calc num and what? Int 2-dimensional.
1-dimensional. Oh
no,
wait,
for,
no.
Yeah, for my
No, because you're only passing. Oh, num is an array. My bad.
Right. Remember, num was our 2-dimensional array, and then we pass in our row, which is int, and then we pass in another int, which is our average, which is a single dimensional. Now, the order in which these arguments are listed, how would I say it? It is important, but it's not important to list them in a particular order. You list them in the order that they're declared in. If I declare them to be this way, then I need to see a what? 2-dimensional array listed here. I need to see an integer variable listed here, or some just single integer value referenced here, or I could say num sub row, which would be what? An integer value, or and then here a single dimension array here. And then when I do my function definition, I should do the exact same thing. Okay? All right. So now, so it is important to follow this. I don't have to have my 2-dimensional array first. I can have it last. But if I do that, then I'd have to move num last. Everybody understand it? So this is not.
Don't you need to change your functions to int so you can return the values?
Because an array, anything you do to an array is automatically done. Remember?
No, I don't remember.
An array is a pointer. The array, the array is a memory address, really, which is a pointer. So it points to that address, and then whatever you do to that array, when I pass that array, is automatically done to the entire array.
I see. Okay.
Right. Now, if I send an individual variable, you know what I'm saying, where the scope was in the main, then I would have to pass the value back in order to print it. I think we did that in 193 where like say we declared a value for a number and say number is equal to whatever and print out the number. Then we pass number to another function and we multiplied it, printed it out, but when we returned back to the main, we thought it was going to be the double value that it printed out, but it was the original value because of the scope. You got what I'm saying?
Yeah.
Yeah, because of the scope of the variable. Yeah.
I'm just looking at my code now and thinking, what a waste of time I've
Yeah, but at least you learn. You learn something. Yeah.
It worked at the end of the day, but I'm learning that it can be done differently.
Correct.
Easier.
Yeah. Now, why this calc? Now, when I do void calc, and what it was, calc num, I think I called it calc num. Yeah, calc num. Now, we had, we could call them somewhat the same, int, and what we want to introduce, we can introduce numbers and, my fault, the row, but then what? Columns, all right, fill M. And then our integer value, which was what? Row, and row coming from the main, which is row. We just didn't change the name. And then we got AVG, which is an array, which is our average. Okay. So now, I got to put the data type, which is int. All right. Now, I didn't semicolon. Wow. Now, what we need to do here is calculate. So in order to calculate all of this, what I'm gonna do, to save time, I'm gonna just copy this information, but we're gonna go over it. All right. All right, I'm gonna paste that. I'm gonna paste that back, then I'll paste this here. All right. What happened? All right. So now, what we need to do to calculate our average is
in your function top, you have, you need to get rid of everything else.
Yeah, I don't know what happened. I did something and something happened. All right, so now we starting at 0. Now you got to look at this. Let me go back here. Those students who had an odd number at the end of their L number, they were to did the average like these three going across, correct? So what? I need to read the first, second, third, get the average, and then go to the next one, right? So what happens is, in here, X is 0, I'm on row 0, then I wanna read row 0, first column, which is 0, the next column, and the next column. So in here, what I'm gonna do is, I'm gonna do this.
You can create it,
Right, so yeah.
You could just do a plus equals.
Right. Int tote, all right, equals 0. And like you say, I could just do plus equal here, all right? All right, so now what happened? I introduced a new variable in calc number, but each time I go to a new row, a new row, I'm gonna do what? I'm gonna set my total to what?
0.
0, so I can get the true average of those three numbers, not balloon it from every other number of the previous rows, all right? So that's why I set it to 0, because I wanna do it for each individual row, each student. Then, so I'm calculating, I'm adding this to this. Once I get out of it, see, that's why you got to know where them brackets at. Before I go back out to go to the next row, I want to say AVG, right?
That's not inside the loop.
Right. Oh, yeah, that's right, though. Yes, I am. I'm correct. Because, see, before I go to the next row,
I see. Yeah,
right, right. See, this one going to keep me on the first row.
Mm-hmm.
Gonna go 0 to whatever. Then it kicks out, and then they're gonna give me my average, then I'm gonna increment again. So average sub X, you got me? My row. Average for that row is equal to this total, right? If I could type, divided by what?
What is it? 3, I think. Yeah.
R.
Column, right?
Right. You see what I'm saying? So you see how if you do it that way, you don't have to go back and keep changing things because I'm using these variables. So they tell me, oh, my program got 15 columns. No problem. Boom. Change it at the console. It's done. Right? So now each time we go through, it's gonna find the average and do whatever. Now, so let's do this. Let's say, okay, well, let's see if we can print our averages out. So I'll calculate an average. And then I'll just put a cout statement here. I'll do this. New line, AVG. I don't want a new line, though. I'll just leave it like this. AVG. And yeah, and I'll end it. And I'll do new line. And before I go back, well, that ain't gonna do nothing now. This here, this gonna go all the way across. No, that's right. No, that's right. My fault. I just want to print out each app. I can put in line here. Yep. Because they're gonna give me each one on the new line. Yeah. So I could leave that in or take this out. It don't matter. All right. So let's run it. And this is just a little test to see what my average is before we go to the next one. All right. And you can always do that in your program just to test it to see what's going on. So look, what happens? Let's go back here. Let's come here. So 100, 100, 100, average what? 100. 190, 100, 96. So what? If I take 5 and put here, and take 5 and put here, well, not 5, 4. Take 4, well, yeah, take 4, it'd be 94. I take 4, well, I guess that's the right average. And then 95 for this one. Yeah, take 2 from this one and put here, then it'll be 95. Wait, 3. Take 3 from this, 95, and 1, right. It'll be 96. 95. Is that correct? I think it's correct, though. You might gotta make sure. But I think it is. But it's always best for you to check it, though. But I think it's correct. 99 plus 95 plus 92. Right, it's 95.33. That's right. So it's correct. So the data is correct. But you see what's happening now. When I print out my actual output, let's go to that part. To print out the actual output, I want the name, the scores, and the what? Average, correct? So yes, I want to print out the name, the scores, and the average. So now what I'm gonna do, I'm gonna create a function for the prototype, PRT num. I'll just call it that. I want to print out num. Well, no, I'm in the wrong place to my prototype. I could start there, but let's start with the prototype. Okay. Okay, void PRT num, and I want to int. I want to print out. All right. I want to print out my number, and I could have put string. I'll do that. I'll do string. All right. I'm gonna print out the string, which is the name. I'm gonna print out the array. I'm gonna pass the row, and then I'm gonna pass the array. I mean, yeah, the average array. All right. So you see what in my mind, what I'm saying I'm doing, and I'm listing the information as what I'm thinking on doing. So in here, now I have to say, okay, I wanna call PRT num, and when I call it, I want to pass my string, which is what? Name. All right. I want to pass my two-dimensional array, which is what? Num. I want to pass my int, which is my row, and then I want to pass my single-dimensional array, which is my average. Yeah. All right. So everybody saw how I did that, right? And why? Why I got name? All right. So why I have an error on name? Name. Why name is? Okay, name is 4. That's right. Name is a string. Oh, it's an array. Remember, this is an array also. So I messed up, right? Name is an array. See here, we got them curly braces. So name is an array. That's why I had gotten that error. I had an error here. So now, let's do our function. So here we go. Void PRT num, and then we're gonna have a string, and I could say nm, right? And then what's for the numbers was a score. I'll call that numbers again. Int numbers, okay, that, and then column. All right, and then our row, int row, and then int avg. All right, so now this is our data. I mean our header file. I mean our function header. Get me right. Now we want to print out our data. Remember how we printed it out? Remember all I did was I copied that information, and I'll just copy this again. But remember, I'd have to know what I did. You can't just start copying or whatever. I'm gonna copy this, and I need to change some stuff. And I'll go into here, and I'll paste. Now, what it is, I need to change this to what? Cout, right? Remember, cout that individual number. But I need to put spaces in them and whatever. So I can do the set W or whatever, but I'll just put a space here like this. So it won't be aligned or nothing, but it'll have a space in front of it. All right. All right. So before, each number printed. Now, but I want to print out the name. So I need to fall in the loop. All right. Fall in the loop and do what? Cout the what? Names of what? My names are what? All on a row. So what? Name sub X, correct? I have to print out name sub X, right? Or not name, I change it to NM. My fault. Because you see here, I change it to NM. So name is being passed into NM. Now, okay, so I'm printing out the name, falling in the loop, I'm spacing, printing out the first one, and I change. No, that is numbers. I need to do my directives. All right, numbers, and then they're gonna print the second one, then they're gonna print the third one, and then after I print my 3 numbers, before I go back to the top, I wanna cout, and I wanna output AVG sub what? Sub X, because X, it has 4. So now, that should print my data, all right? Okay, so now when I run my program, this sub X, this sub X, this sub X. Yep, this should be sub X. This. Why it's not allowing me? AVG. Y is not allowing X. Print out AVG 1, 2, 3, 4. Why is it not allowing X to be printed? Oh, this is why. I don't have it as an array. Yeah, that's my problem. And see, that's it. Yeah, we have those issues. So now let's run it. Let's debug it. And here we go. And bam. So remember, oh, I left this one in. But look, the name, remember this was before. I left that one line in the process. So Kevin, 100, 100, 100. His average, 100. Brad, 100, 90, 90 and 100, 96. Thomas, whatever, average this. Others, scores, average this. All right? So you see what happens? So now, the thing is in here, if I wanted to print out a column heading, my column heading would go before this. You understand? Which have names. So if I do a C out, and I'm gonna just put column heading. And you can use the IOMAN IP functions to output that stuff. To output your columns, everything, fit it in a column. Now, and I'm gonna take this out. This one statement. Where is it? Yeah, this one statement here is what printed that other stuff. And so now you're gonna get name. See, your column heading would have name, score 1, score 2, score 3, average. So that's where you would print that, and then you'd have your information printed below. Now, that's for people with odd, I want to say it, an odd number at the end of their name. If you had, now everybody else, any questions about the ones with the, this is the one for odd. Anybody with questions about the problems with odd numbers? With an odd number at the end of your name. Because this is how your program looks. For people who had an even number at the end of their L number, it's a little different. And I'm about to show it to you, but I want everybody who doing it this way to understand that this is how you do it this way. So if you catch it at the end and you try to do it the way I'm doing it, you're going to be doing it wrong. You're going to be doing it for the wrong sign. Well, you're going to be doing the wrong sign. So I can move on to those who had an even last number, right? Hello? Okay, yeah, whatever.
Yes.
All right. So now, those who had even numbers, you're going to read in those numbers the same way. Remember? Sub 0, sub 0, 0, sub 1, 0, sub 2, 0, sub 3, right? The thing is with your assignment, you are supposed to try to find the average going down, okay? You're finding the class average. And what I'm gonna do, I'm gonna put, so I could test it to make sure it's doing it right. And then I'll put 90 here and we'll see, All right, so you're finding the averages going down. So how do you do that? All right. So given the program we've just done, everything is basically the same. The reading and the in of the data is the same. The writing out of the data, the output, the same. The only difference is you're gonna have to interchange your nested loop. Well, you're saying, well, why, Mrs. Vesta? What's the importance of that? Rather than you going, okay, this plus this plus this, you're gonna have to say this plus this plus this plus this, get the average. This plus this plus this plus this, get the average. This plus this plus this plus this, get the average. So we're gonna have to swap the loops so that you'll do column 0, row 1, column 0, well, you're going to do row 0, column 0, row 1, column 0, row 2, column 0, row 3, column 0, row 1, column, row 0, column 1, row 2, row 1, column 1, row 2, column 1, row 3, column 1. So you stand on that same column, all right? So the way to do that is, let me get back to here. All you would do is, rather than do row here, you would do, well, I could change X, but you'll leave X and Y. You'll change this to Y, all right? Change this to Y, all right? And you change this to columns. And you change this to X. And you didn't, yeah, you did, unless you'd have to change it in the other one, but I'd say leave that there. Change this to X. And change, well, I need to change that other thing to row. And this is X. And this is Y. All right, but you also need to change what? This. All right, now your array for average, you're gonna only have column number of averages, right? So you change that to column, not row. Now, in here, this stays like it is, but look what happens. When I'm at column 0, I'm gonna go row 0, row 1, row 2, kick out, and well, this should be, so Y. All right. Wait. Right. So then when I kick out, I'm gonna go to column 1, and then gonna go row 0, row 1, row 2, row 3. Then they're gonna kick out and they're gonna go to column 2. Then it's gonna go row 0, row 1, row 2, row 3, and then kick out. So everybody understand what happened. Now, well, another thing you're gonna have to change based upon what we did is your output of your average, all right? Now this becomes printed after everything is printed, and it'll be in a loop by itself. So now we'll take this out, and we'd have to have a loop that's gonna print going across for the first column, the second column, and the third column beneath the output data. So we'll have to do that outside of the entire array. So we'll have for int, and I'll just say X again, equals 0, or I could use any value, equals 0, X less than, and it's columns, right? X plus plus. Now, what we'll do, see out, and I'll just put some spaces. You'll be able to do the column width and print nothing, then your average. I'll do that. I'll do it. I'll do AVG. I'll just do that. All right. We're going to print out AVG. I have to print out that before that. All right. AVG. And then here within this loop, I got a semicolon. And then within this loop, I'm gonna see out what it is. AVG sub X, all right? So it's gonna go for each column, all right? AVG sub X, and then I'll do, and I'm not gonna space it. I could do the set W, but you'll be able to do that, and I'll put space. All right. Okay, so now, and it's gonna print them all going across, okay? Now, so let's run it. I think I got everything in order. We'll see. But that's what you'd have to do. Change, just rearrange the, wow, wait a minute. So it printed Kevin. I didn't put my inline here. I need to put an inline at the end of every. Okay. Okay. So here we go. And now you're going to see, all right, see here, the names. Here the name, and look, average. Wow, the first one is wrong. It got 133 because I used the same information. Oh, did I? Oh, I divided by column. I was supposed to divide by row. Where is it? 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 Well calculated. Where's my average calculation? Yeah, here, I got to change this because what? I don't want to divide by columns because columns is 3. And I don't want to divide by 3. I want to divide by row because what? With my row, I have what? 1, 2, 3, 4. So I need to do the 4 in the 4 numbers. So that's why my values came out wrong. So let's run it again and we should get the right answer. And here we go. All right. 100, 100, 100, 100, 100, average 100. 90, 90, 90, 90, average 90. 100, 100, 90, 92, average 95. So see how it was done? And like I say, with the set W, you can have all that aligned so that it's even. And I didn't use a set W. I just outputted the data to save time. So that's how you would do the program. Anybody with any questions? Any questions? Now, grant you, this program does not show you exactly how to do the assignment. And what I mean by that is you have a 15 by 5 two-dimensional array. It does show you how to initialize your names. I had 4 names. You're going to have 15 names. So things like that, you're going to have to piece together to try to get your program done. The column heading part, I didn't put the name, score 1, score whatever. You're going to have to put that together to make the data come out in order. But for the most part, this is how the program is to be done. All right? Anybody with any questions? Questions? I'm going to open up the assignment, and I'm going to give you a few more days. I guess what today is. Today is Thursday. Over the weekend, I'll give you over the weekend to do the program. And like I say, because if you already submitted it, you can resubmit it because you can just, I'll just grade the last one. All right? The very last one that you submit. I can see which one is the latest submission. All right? So any questions? Now, what I'm also doing, I'm going to post the test. So read through the documentation or the notes and also through the chapters in the book and take your test. All right? Now, the test is being taken through Proctorio. So there is a link, I think in miscellaneous, that you click on that can take you to Proctorio. You'd have to, and I don't know if you're in other classes where you have to do it already. But if you've already done it, you don't have to do it again. But it takes you through an installation process. It's going to ask you to install an extension in Chrome because you have to use Chrome. And then it's going to have 3, well, we're going to start and installing the extension. Then it's going to say done. And then you're going to be able to click on the link to take the test with no problem. All right? Any questions? So I'll post that test so y'all could take. I'll extend the assignment so you can work on your assignment. Now, this is just one of them now. You know, you got the other one. The other one is not as hard as this one, but this one, dealing with arrays. Arrays can be tough. All right, arrays can be tough. So if there's no questions, like I say, I'll see you on next class period. Anybody with any questions? Questions?
Yes, sir.
All right. So I'll see y'all on next class period. All right? Okay?
All right.
All right.